told you in the last class that today we will going to start a new chapter in operating system, which is a very um, important chapter uh, known as memory management. The name of the chapter is known as memory management. Now, uh, memory management, uh, whenever we are talking about memory, whenever we are using the term memory in operating system, then you should understand that we are referring, basically we are referring primary memory. Whenever in our studies we will use this term memory, so at first what should come in your mind is that primary memory. So here also uh, we will try to manage the primary memory in a more optimum way, so that we can get best use of it. That is as simple as that. Now, before going into the details of memory management, let us try to find out that uh, what is memory management. So basically, memory management, if we see, we will found that memory management, it is the functionality, it is the procedure, it is the technique of an operating system by which every operating system handles or manages primary memory. As I have told you that whenever we are talking about memory management, we are basically talking about primary memory. So in memory management, uh, whenever we are saying uh, that it is memory, so that means primary memory, and it is the responsibility of every operating system to manage the primary memory in a better and more efficient way. That is the basic thing about memory management. Next, there are some additional responsibilities that has to perform an operating system uh, when it managing memory, and those are: memory management keeps track of each and every memory location. Now if you see, if we see a structure, if we see a structure of a primary memory, uh, you will found that our memory, our primary memory, it is looks like this. Our primary memory looks like this. You know, I probably primary memory looks like this, and each and every segment, each and every slot, we should say, of primary memory, it has a number, it is an address. Maybe this is 100, maybe this is 200, 300, 400, and like that, so on and so forth. So this is basically the structure of the primary memory. So memory management, in memory management, we have to keep track of each and every memory location. This is a memory location, this is another memory location, this is another memory location, this is another memory location. So we have to keep track of each and every memory location. Now, among these memory locations, some memory locations can contain some data, some memory locations cannot contain any data. Whatever it may be, whether the memory location is containing some data or it's not containing any data, whatever it may be, all the memory locations will be tracked by the operating system. Next is operating system also checks how much memory is to be allocated to a process. Because suppose you have two processes, process Pi and process Pj. Now suppose size of process Pi is 1000, suppose 500, and size of process Pj is suppose 200. Now operating system has to get a vacant position. Operating system has to get a vacant position where it can place this process. So for that, operating system should have all the informations about the current status of the memory, that whether a process which wants to come to memory, because when a process will come to memory, when a process will want to come to memory, when CPU, when that process will be going to execute, when a process will be going to execute in a CPU. So before going to execute, before executing it, we need to bring that process to the primary memory. You know that, because everything system access it from the primary memory. So obviously, before going to a CPU, a process has to be there in the primary memory. And from where it will come to primary memory? From the secondary memory, that is hard disk. So from secondary memory to primary memory, from primary memory to CPU. Again from CPU to, it will go to primary memory, and then again if it is needed, that information will be flushed out to secondary memory. That is the cycle, you can say. So suppose CPU needs to execute process Pi, which is currently in secondary memory. Suppose which is currently in secondary memory, that is hard disk. Process Pi is there. It wants to be executed by the CPU. So process Pi needs to come to primary memory first. Yeah, Ronit, tell me.
স্যার একজন জয়েন হতে পারছে না, গ্রুপে মেসেজ করেছে।
স্যার কৌস্তব জয়েন হতে পারছে না।
পারবে এবার, বলে দে। So from hard disk to that primary memory, the process has to come to the primary memory. Now, when a process can come to the primary memory, if the adequate space is there in the primary memory, if suppose the size of the process is 500 and I don't have adequate vacant space in my primary memory, then this process cannot come to primary memory. As simple as that. So to control this procedure in a systematic manner, an operating system should have all the informations about the primary memory. So for that, so to do that, the operating system should have all the informations present to it, that which process is allocating how much of memory, which memory portion is free and how much memory is left over there. All these informations should have to the operating system. And that's why I said that it checks how much memory is to be allocated to a process. All these things are controlled by operating system. Remember, whatever we are talking, all these things are controlled by operating system. It happens in your system. You don't have to bother about that, as because operating system is doing that for you. And every operating system does that. Now, so this is the basic functionalities under memory management, what we get. This is the basic functionalities under memory management, what we get. Now, how it happens? How operating system is managing this memory and all that? So, in our memory management chapter, we will try to understand this procedure, that how these things are controlled by operating system. So to understand that, we have to go through some systematic procedure, and we have to know several additional functions, methods. Function means I'm not talking about C function. Function means different operations that is performed by operating system. Now, as you see, the structure of the memory, you can consider this structure as an array, large array. Of words. Each of which has some specific address. Now there is a term known as address binding. There is a term known as address binding. What is address binding? Let us try to find out what is address binding. Basically, listen minutely, okay? If you have any doubt, please tell me. Basically, address binding, it is a process of mapping from one address space to another address space. Now, what is mapping? You must have done mapping in set theory. Suppose I'm saying this is X, Y, Z. Now, suppose here it is A, B, C. Now, suppose I'm mapping it. I'm mapping it like this. X to B, Y to C, Z to A. Can anybody tell me what kind of mapping it is? What is the name of this kind of mapping? Because you have done it in your set theory. In mathematics.
Many to many.
Is it many to many?
One to.
Is it many to many? I have
one to one.
This is 1 to 1, right? This is 1 to 1 mapping. That means X will be mapped to B. Yes. 1 to 1. X will be mapped to B, Y is mapped to C, Z is mapped to A. So this is the mapping. That means X is related to B, Y is related to C, Z is related to A. As simple as that. This is a 1-to-1 mapping. We say 1:1 mapping or 1-to-1 mapping, whatever you say. Now, in that way, there are different other kind of mapping: one to many, many to one, many to many. When it will be many to many, if I instead of like this, if I make X to B and then X to C, then Y to C as well, Z to A. Here it is X and Y both are mapped to C. So that means again X is mapped to B, X is mapped to C. So this can be many to many mapping. So that like that. So address binding is also doing the same thing. Question is how and why. Why I'm saying this mapping is done in operating system and where it done. Basically, in operating system, we found that we have two kinds of addresses. We have to deal with mainly two kinds of addresses. One is known as logical address. Another is known as physical address. For your reference, I want to mention here is that when I will teach you computer networking in subsequent semester, probably I will take that class again. So in computer networking also, we found these two terms: logical address, physical address. Well, logical address means your IP address of your computer system, of your network, and physical address means the address of your network interface card, which is there in your motherboard. But that concept is completely different with this concept. I'm not going to that concept. It is some completely different. Here, logical address means the address which is generated by the CPU. Logical address means the address which is generated by the CPU, by CPU. This address is generated by CPU, Central Processing Unit. And physical address means the address that refers to the location in the memory. The address that refers to the actual location of the memory. That is physical address. So you can think it like that for your simplicity. Logical address, that is address generated by CPU. Physical address, that is the address of the RAM. So suppose a data item X, which is there in hard disk, that has to be bring to memory. CPU knows what is the logical address of this X. CPU mention that address to the operating system. Now, operating system will convert that logical address into the actual address of this data location X, which is known as physical address. Here some translation is done. By an unit, by a mechanism known as memory management unit, MMU. The responsibility of this MMU, I will show you that later on. The responsibility of this MMU is to translate the logical address to the physical address, which is the actual address of that data item in the RAM. I hope you have got my point. If not, please tell me. Or I will request somebody to explain whatever I have said about this logical address and physical address. Again, I'm repeating. The address which is generated by CPU is known as logical address. That address undergoes through an unit which is known as memory management unit, and it is converted to physical address, which is the actual address of the data item in the RAM. And this procedure, the logical address to physical address conversion, this procedure, okay, the technique is known as address binding. And mathematically, we can think it as mapping, as if we are mapping to logical address to physical address. Now, suppose this is logical address and this is physical address. This is the set of logical address. This is the set of physical address. Here, one MMU is there. That MMU is converting this logical address to physical address, and the mapping is going on. That is the overall thing. Now tell me if you have any doubt up to this.
স্যার এমএমইউটা কি মানে ওটার কাজ
memory management unit. MMU stands for memory management unit, which is actually converting this logical address to physical address. এই কনভার্সনের একটা প্রসিডিওর আছে, তো সেই প্রসিডিওরটা দেওয়া আছে MMU এর মধ্যে। MMU সেটাকে কন্ট্রোল করছে, কোন লজিক্যাল অ্যাড্রেসটা কোন ফিজিক্যাল অ্যাড্রেসে ম্যাপ করবে সেইটা কন্ট্রোল করছে MMU। বোঝা গেল? কিভাবে করছে আমরা দেখব, ডোন্ট ওয়ারি, সেটা আমরা দেখব। সেটাই আমাদের মেমরি ম্যানেজমেন্ট পড়ার উদ্দেশ্য, ওয়ান অফ দা উদ্দেশ্য। যাই হোক, এই যে ঘটনাটা, এই যে লজিক্যাল থেকে ফিজিক্যাল কনভার্সন, এই যে ঘটনাটা, দিস ইজ নোন অ্যাজ অ্যাড্রেস বাইন্ডিং। এই জুমের 40 মিনিটের বাইন্ডিংসটা না ভালো লাগে না। যাই হোক, সো দ্যাট ইজ অ্যাড্রেস বাইন্ডিং। Now this address binding, তার মানে লজিক্যাল থেকে ফিজিক্যাল অ্যাড্রেস কনভার্সন, এটাই তো অ্যাড্রেস বাইন্ডিং। এই অ্যাড্রেস বাইন্ডিং it can be done in 3 ways. এই অ্যাড্রেস বাইন্ডিং মেকানিজমটা এটা 3 ভাবে হতে পারে। একটা হচ্ছে কম্পাইল টাইম অ্যাড্রেস বাইন্ডিং, একটা হচ্ছে লোড টাইম অ্যাড্রেস বাইন্ডিং, একটা হচ্ছে execution time address binding. 3টে টাইপ অফ অ্যাড্রেস বাইন্ডিং মেকানিজম আর দেয়ার। কম্পাইল টাইম অ্যাড্রেস বাইন্ডিং, loading time address binding or execution time address binding. Three kind of address binding mechanisms are there. Now, what is compile time address binding? You know that when you're running a program, at first it is a source code. Now go to the C concept. At first it is a source code. You have written the program. Then after that, that program gets compiled. Now, if you know, during the compile time, that means when the process is compiling. So if you know during the compile time where the process will reside in memory, then the absolute address is generated. That means you know that, okay, during the compile time, you know that the process will reside in memory at location 200. You know, suppose. You means your system. You means your operating system. Nothing is done by you. You means your operating system knows that when you are compiling a program, during that compile time, your operating system knows that the process will reside in memory location 200. Then the things become simpler. Because that is the absolute address which is generated. That means the physical address is embedded during compilation. So when you know that, okay, after compiling, I have to place that process into memory location 200. So the things become simpler and it will be first. Very first, that I know that my process, it will be compiled and it will be stored in memory location 200. So I know the absolute address of this process, that is 200 in memory. So things become simpler. So that is basically compile time address binding. So compile time address binding says that during the compilation, you know where you have to place the process in memory. As simple as that.
একবার বলুন স্যার, that
During the compilation, the operating system knows that during the compilation time, the process will be stored in the memory location 200, suppose. So it becomes very simpler, very simple for the operating system that, okay, I will compile this program and I will place it to memory location 200, which is its actual memory location, absolute address. So the thing will become very simple and fast also. This processing will be very fast because there is no other intermediary steps. conversion of logical to physical address with the help of memory management unit. Things are becoming simpler. So that is basically compile time. So compile time address binding says, you know, during the compile time where you have to place the process in the memory. And memory means, always I'm saying that memory means RAM. Whatever I am saying by memory, that means RAM. Please consider it as RAM. So there is compile time, address binding. Next is loading time address binding. In the loading time address binding, loading time means, loading means what I want to tell over here is that after compilation of a program, suppose C program in your case, after compilation, what kind of file is generated? Can you say? After C, in C, after compilation, the file which is generated, what we can call it? সিতে কম্পাইলেশনের পরে যে ফাইলটা তৈরি হয় সেই ফাইলটার নাম কেউ বলতে পারবে?
Sir, .exe executable file.
In more precise way, more general way, do you know how a C program runs in memory? At first, there is a source program. Then, the next step, this source file is going through the compiler or assembler. Then, the file which is generated, which is known as object file or object module, whatever you say. So the thing what you are saying, .exe, that is you are saying about execution. I'm telling you in between compilation and execution. If you run C program in Linux environment, because you see in Turbo C or whatever compiler is given over there, you cannot see the intermediary steps. If you run through it in Linux environment from command line, then you can understand the intermediary steps, which is known as object file. And that object file or object module, which is just the compiled version of this source program, which is not understandable by human.